we'll all have debt, and this section is about being smart with it. Generally, you want to try to get, if you're paying the interest, you want to get the lowest interest rate that you can. So we're going to look at a variety of problems today. There is one new formula, and here it is. You should see that it looks a lot like the other formulas. Zoom in a little bit. It uses the same variables. It uses that I is equal to R over M again, same idea. N on the TVM solver looks like capital N, but that's the M times T. So if we're going to use the TVM solver, we're going to need to have it broken down into this level of specificity. In this section, the future value will be 0. So in the TVM solver, when it comes to, and notice there's no future value term in this equation. The presumption is that you take out this loan, and then once you make all the payments, then at the end you won't owe anything, nor will you have accumulated any chunk of money at the end. Basically at the end, when the loan is paid off, the future value is 0. And payments are made at the end of the period. So in that one version of the last line of the TVM solver, where it says end and begin, I forget which one comes first, but we always want to select the end. And that is typical of what we would say is an ordinary annuity. And most all loans you would get today are based on ordinary annuities. All right, but that's it. So now I just want to go through some problems. That's the formula that you have, and there's nothing new in terms of defining variables. And so it's just a matter of taking a look at what are the applications where this formula is used. So the first couple are not so interesting. It's just like you did in the worksheet. You know that I is equal to R over M, and you know that N is equal to M times T. So as you read the problem, monthly payments, okay, they give you this piece of information here that's okay, but it's not useful in this problem. Made for 4 years, so T is equal to 4 to repay a loan at 7.2%. All right, so that is decimal that we usually use there. And then finally, compounded monthly, the M is 12. All right, so you'll have a couple of problems just understanding this up here. If you did insert these versions into this formula, the formula would look like this. Present value equals the payment, and then you have 1 minus 1 plus R over M to the negative MT. Right, so that's the numerator. And then the denominator is I again, so R over M. And you can see that they're using the TVM solver variables like present value, payment. The M is the payments per year and compounding per year. T is the number of years. That doesn't appear anywhere in the TVM solver, but MT does. And then R is the I percent, except you have to convert it to a percentage as opposed to a decimal number. All right, so then the rest of this would be just for number 7. You have the interest rate, 0.072, and if you divide that by 12, what is that, 0.006? And then the number N is M12 times T4, so 48. All right, that's the only one I'll do in that section. Other ones are very similar. All right, the next chunk, it says use formulas 5 or 6, and I think 5 is this one here. You see number 5 there. There's 5, and maybe 6 is on the next page, right here. So they're both equivalent formulas. It's just one of them is solved for the present value, and the other one is solved for the payment. But they're equivalent. All right, so maybe I'll do 2 from this section. And the first one is number 18. I'm going to write down the formula. For number 18, it says that the payment, or the present value, is 14,000. Imagine that you're taking a car loan out for $14,000. The N is 72. So that would be, let's say you're making monthly payments, although we don't know that information. You're making monthly payments for 6 years, which is typical on a car. The monthly interest rate is 0.005. And if you multiply that by 12, you'll see, just like in one of our problems today we did, that turns out to be an annual interest rate of 6. But we don't really know that because we don't know how those numbers are broken down. So what we're going to do is we're going to solve the equation, plugging in all the numbers we do know, and trying to find the value of the variable we don't know. And in this case, it's the present, or the payment. All right, so plugging everything in. Notice the exponent here is negative, so it's a negative 72. And then again, we're dividing by 0.05. So all of this stuff in parentheses here is just a number. So I would say go ahead and use your calculator to evaluate that number, and then we'll divide the number both sides to find out what the payment is. So I'm going to put this into the calculator. So 1 minus, then in parentheses, 1, I'm just going to add those two numbers together, and then raise that to the negative 72. Now, since I didn't put parentheses around the entire numerator, I have to divide this out first, and now I'm going to divide by the 0.005. All right, so 14,000 equals the payment, and when we evaluate that whole number there, we get 60.33951394. Again, if you don't want rounding error, you should leave as many decimal places as possible in your intermediate results. And then the payment, if we take 14,000 and divide by that number, which is my last answer, then it's 232.0204,305. All right, and then once we get that number, we would write down the final answer in a form that's reasonable. The payment would be $232.02. All right, the other one that I would like to do in this section is, well, one of these ones down here, so maybe we'll do number 20. We'll start once again with the formula. Plug in all the numbers we need, and then decide, what it is exactly that we have to solve for. And once we know that, then, oops, not 72, this is negative n. All right. Okay, so we have the present value is 20,000 in this problem. There it is. We have the I is 0.0175, and that's going to appear 2 times in our formula. And then the payment is $500. And the question is, how many payments do we have to make of $500 to pay off this $20,000 loan? Now, in this case, if you just took 20,000 and divided by 500, I think you get 400, right? 40, sorry, 40. Now, 40 payments, but that's if you just didn't pay any interest. Because you borrowed this money over a period of time, you're going to also have to pay interest. So it's actually going to be more than 40 payments. So let's take a look. 20,000 is one we're going to solve with algebra. And if you don't like this method, then there's other methods that you can use, particularly the graphing method. All right, there it is. And then the rest of this will be algebra. So I'll divide both sides by 500. And we'll get this 500 off there. And then I'll multiply by 0.0175. And that'll get this 0.75 off there. All right, so it works out to be a nice 0.7. All right, so that would get rid of that and that. So what we have left on this side is 1.0175 to the negative n. All right, I'm going to subtract 1 from both sides, -1 and positive 0.7. That'll get rid of the ones here. You get a negative. Multiply both sides by -1, and that'll make everything positive. Take the log of both sides. ln of 0.3 equals, and one of the properties of logs will enable us to take this exponent out front times the natural log of 1.0175. We're going to divide by both sides by negative ln 1.0175. Negative ln 1.0175. And that'll get rid of the negative sign, that'll get rid of this whole log expression, and we'll be left with n. All right, so it's a calculator exercise from here. We have the natural log of 3, and we're going to divide by negative natural log of 1.0175. Natural log of 0.3. 69. All right, so we thought it was going to be 40, but because of the interest, we actually have to pay 70 payments. I think in a lot of problems in this section, they're going to say, well, if you do have a fraction like this, then round up. Because if you make 69 payments, you're still going to add, there's still going to be a payment left, a fraction of a payment left. So since there's a fraction of a payment left, I think they want you to round up and say 70 payments. It's going to take about 70 payments. All right, so that's the algebra. When it happens in this section, you're going to be using it only for this formula here, this one. Most of the other problems will be done with the TVM solver. So let's take a look at these problems. When you show work on your test, I'm just going to ask you to write down all the inputs from the TVM solver. So in 28, American General offers a 7-year ordinary annuity with a guaranteed rate of 0.0635. And remember, for the TVM solver, that's going to go in as a percentage, 6.35. Compounded annually, so that tells us that the M value is 1. And the M value is the same thing as the payments per year and the compounding periods per year. So all of those are 1. How much should you pay for one of these annuities? So if you want to receive payments of $10,000 annually, so the payment is going to be $10,000, but this is a cash out payment, so we're going to put a negative in front of it. And then the period time is 7 years. And what we're looking for is the present value. What is this thing that you would pay off in 7 equal payments of $10,000? And so it's probably going to, because you're going to be charged interest over that 7-year period, you're probably going to be starting with an amount less than $70,000, because you have to pay interest, 7 years worth of interest. And you're going to start off by owing about, 60,000, 50,000, something in there. So anyways, do some thinking about, what is a reasonable answer? So if that you make a mistake, you'll be able to detect it. All right, let's go to the TVM solver, enter in everything we need to enter in. The N is equal to M times T. And so our M in this case is 1, and the T is 7. The interest rate is I%. In this case, we enter the percentage version of our rate and not the decimal version. Present value is going to be what we're looking for. So there's where we're going to do the alpha solve. The payment is negative 10,000. And the future value for these problems will be always 0. And the payments per year is equal to the compounding periods per year is equal to 1. And because they told us this was an ordinary annuity, the interest is calculated at the end of the period. So you want to make sure that end is selected there. Okay, so again, the TVM Solver, you want to push the apps key here. Oops, what was that? Finance, number 1, and then the TVM Solver. And we'll enter in our numbers, 7, 6.35. I'll just pass over the present value because we're going to come back to it and calculate it. Negative 10,000, 0, 1, and 1, and then end is highlighted there. Okay, I'm going back over to the one that I skipped. And so here's what the screen looks like before you calculate the thing that you want to calculate, present value. Our guess was that it's going to be, 60-ish thousand, because in the end, we're going to pay 70,000. And part of that is interest. So let's see what it is. 55,000. So you shouldn't pay more than 55,000 for this annuity if you wanted to pay you 10,000 over 7 years. All right, and then finally go to the problem and read it again. Make sure that you're going to report what it is that they're asking you to report. All right, so they just want to know what the present value is. That's a dollar amount, and we'll round this, unless instructed otherwise, to the nearest penny. One of the applications of the present value is it's the loan amount. So a lot of times the present value equals the original loan amount. Okay, you'll definitely want to get a decent credit score, and a decent credit score would be something kind of, set in the 750 range. You can go to one of the credit bureaus right now, and you can see if you have a credit score. And it's not that important right now for you, but if you want a credit card, if you don't have a credit history, you might not be able to get a credit card. And if you're unemployed, you're not going to be able to get a credit card. Those are some things that they'll ask for. My daughter just went online because they had this Amazon credit card that they were offering. And if you apply for this credit card and you get it, they'll put $70 into your account. And she said, and so I did it for my mother, and she got her 70,000. But my daughter, who is unemployed right now, as soon as she answered that, checked that unemployed box, it didn't matter if her credit score was over 750, over 800, in fact, they wouldn't loan her money because she doesn't have a way to pay it off. So they thought. But you definitely want a good credit score, because if you have a good credit score, they'll give you the best interest rate possible. These problems will be asked in a slightly different way quite regularly, and so I just would like to do just a bunch of them, just so you can kind of get familiar with the way that these questions are being asked. And number 30, there's a 36-month auto loan. Okay, well, we know that then T is equal to 3. That's because T is in years, but 36 months. So it turns out that in this problem, they gave you that capital N of the TVM solver, because N, capital N, is the number of payments. The interest rate, 5%, is equal to 9.84. If you use the formula, you'd have to enter in that same rate as the decimal number. Compounded monthly, so M is equal to 12. 3 times 12, M times T is N. If you have a fair credit rating, then you can afford monthly payments. Payment equals $350. How much can you borrow? All right. So this is a ploy of a car dealer. When you go in and you might be interested in getting a particular car, and that car might be $15,000, it might be $20,000, it might be $7,000 if it's a used car, but you're more interested in getting a car you like. The dealer is trying to figure out how much the maximum amount of money that they can take from you over a, a 3-year period in this case. And so what they're going to ask you is, how much can you afford? And that's what this problem is. It's like the car dealer asking you, how much can you afford? And then you tell them, well, I can afford $350 a month. So what they'll do is they'll calculate the present value, and that would be the loan you could take out. So then they would know that, let's say that if this present value was $12,000, they would know that that you can afford a loan of $12,000. So what they might do is make sure that they direct you toward cars that are valued at about, say, $11,000, and or at least they'll direct you at a car that they paid $11,000 for, so they can make $1,000 off the sale. All right, so these problems aren't so bad if you just have a kind of a knowledge of the TVM solver. When you go to that screen, it's going to look like this. And the idea, don't forget to put the future value is 0. And as long as you have all of the variables with numbers attached to them, except for one, and that's the one you're trying to find, then this thing is a very powerful tool. We've identified N to be 36, I% to be 9.84. We know the payment is $350, but remember, we got to put that in there as negative $350. And generally, we make monthly payments when we buy a car. So we know all of the inputs except the one we're looking for. This is the value of the loan that you can take out if you wanted to buy a car. If you can afford $350 as a monthly payment, then this is the value of the car you can purchase. Well, the loan amount and the value of the car is almost similar. All right, so let's go ahead. 36, type in all these numbers. Present value, I'm just going to stick a 0 there and come back to it. And notice when I hit 12 and I hit enter here, it automatically changes this one. It's assuming that we're working with an ordinary annuity. And in our problems in this course, in fact, this will not deviate from the word end. So leave it as end always. Come back up and calculate the present value. Okay. 3 years, 10% interest rate, 350 payments. Just think you're going to be making that 36 times. And 36 times 350 is that. And but you have to pay some interest. So I'm thinking somewhere up around 14, 15,000. Let's see what it is. Oh no, I had to go the other way. Sorry. This is what you can afford, so that if you make this 350 payment, you're actually making $12,000 worth of payments. Is that what it was? 12,000? 12,600. So there it is. 10,872. So the car dealer is going to direct you toward cars that are about $9,000, so that they can make about $1,800 off you. So never give the car dealer your financial information. It's none of their business. All right, so 10,872.22578. And then we interpret that number as a dollar amount and round to the nearest penny, unless instructed to do otherwise. Number 30. Okay, go ahead and try number 36. Just give me the answer, put it in the chat, see if you're picking this up. This is pretty straightforward, this one here. You see it? This whole worksheet was put up on e-learning as part of the notes for today. And so you can get a copy of all these problems after class. Everything we worked out in class will be there. Imagine 23% on a credit card. It's not uncommon. It says how long. I think online they'll give you more direction, and they might say how many months or how many years. So how long can be even number of minutes, but we never use minutes. But so usually you just get in the habit of converting whatever you get in terms of time, convert it to the number of years. No answers yet. Anybody? Anybody else? Okay, here it is. I'm just going to clear that one out. But the interest rate is 22.99. Here's what the loan is on your credit card. You know, usually it's not a whole lot, but you know, this one's under $1,000. In this section, equate the present value as the loan amount. This is what you owe today. If you were to pay off this loan today, you'd have to come up with $860.22. It's called the present value of the loan. There's the minimum payment, right? Minimum payment of $25. Future value is always 0 and you're making monthly payments. So move up here. It's the only one we don't know. And press alpha and then enter to solve. Alpha, enter. All right, now when it reports this number, since payments per year, compounding per year, 12, this is months, then that's that many months. So I think your answers are good. What I like to do is just scroll to the end and just say divided by 12. And there's the number that many of you came up with. Okay. So n is going to be equal to 56.72641986. 5% is equal to 22.99. Present value is 860. 22. Payment is equal to -25. All right, so what they'll often do is ask you to find out how much interest you paid over those 4.5 years, 4 3/4 years. So if you make that payment right there, let's say it's for 57 months, because you're not going to quite have it paid off after 56 months. That's 1425 for 57 months. And if you subtract the 860, we call the 860 the principal part, and everything else, this is called the total payments. And if you do the subtraction, everything else is the interest. So this is a very, very sad situation, because you only owed 860, but because you couldn't pay it off and you chose to make the minimum payment on your credit card over that 4.5 years, you will eventually pay it off, but this is how much interest you'll pay. There, almost 60% of what the original amount was. Avoid loans if you can. And if you must take out a loan, make it be as small as possible. Okay, so an amortization schedule is a payment by payment listing of what the payment is, how much interest, and then the balance over here. They all, depending upon which one you go to, it'll have maybe a different schedule this way, but but the amortization schedule gives you, for me, the most interesting column is this one over here, because this is how much you'd have to come up with at any time in order to pay off the loan. Okay, so 5 points of extra credit is to, let's say that you're going to purchase a car. And let's say you're going to take the loan out for 6 years, 6-year loan. And let's say that your annual interest rate is 4.375. So find a car you want to purchase, and let's just say that the purchase price of the car is going to be equal to the present value of your loan. It's not quite how it works out, but there's some other things that we'll consider. Usually with a loan on a car, you have to make monthly payments. Okay, so to get the 5 points of extra credit, go to a website that gives you amortization schedules and print out the 6 years worth of monthly payments, 72 rows in your table. So it's not going to be just 6 here, but it's going to be 72 rows. Print it out and then hand it in by next Monday before class. So on the table, provide these pieces of information, the loan. And so, for example, if you knew that it was going to be 6 times 12 monthly payments, 6 years monthly payments, 72. The interest rate, 4.375. The present value will be your car. Now you go out and find a car, and you can play around if you want. If you want to buy a expensive car, yeah, you can do that. But let's just say that it's a $45,000 pickup truck. You can actually calculate the payment here. So that $711.75, this is what that pickup truck would cost per month. That's the number that would appear throughout here. This is your payment. That payment never changes throughout the life of the loan. So you can calculate that. But the amortization table will calculate it for you as well.